All right, our second notes in section 5.3 are going to be called opposite terms and expressions. It's important that we know what these are first before we do subtraction, because we're actually going to use opposite expressions in our understanding of how to subtract polynomials. So the first thing we're going to do is just talk about opposite terms. So opposite terms, as a definition, are two terms that combine to make 0. 0 pairs is another word for opposite terms. That's right. What do I mean by that? Well, if I said, and I'll just give the easiest one, 2x. If I said, what is the opposite of 2x? The opposite would have to be whatever value creates a 0 pair together. The opposite would be negative 2x. And we know that from, and I could just give a value for x. Let's pretend for a second. Give me a value of x. It doesn't matter, any value. Anybody?
4.
4 it is. 4 is the first one given. Let's pretend for a second x is 4. If, and I'll use the word if x is 4, what is the value of this term if x is 4? What is 2x worth if x is 4? That's an easy question. Anybody could just spit out the answer 8. Just say 8. 8, correct? If x is 4, then 2 times 4 is 8. If x is 4, what's the value of this term? Negative 8. And when we substitute a random value for x, we can see how when I insert a value of x, the value of 2x and negative x are going to create negative numbers or opposite numbers, which when we combine those two are going to make 0, right? And that would be the same if I gave you something as complicated as negative 4xy. Its opposite would simply be a positive 4xy, right? Likewise, if I chose random numbers for x and y like 2 and 3, let's pretend for a second x is 2, and let's pretend x is 3, or y is 3. So if x is 2, we'd have negative 4 times 2 times 3. And over here, we'd have a positive 4 times 2 times 3. Now really what we could see is this is going to give us a negative 24 when we simplify it. This would give us a positive 24, which when we assign values to x and y, we can see how when they're simplified, they create numbers that are opposite. When combined, we'll make 0. And this will happen with anything. So really, when the coefficients are the opposite number, the value of the expression becomes the opposite. Yes? Y. Right here. It's a miswritten y. Yeah. Conversely, or not conversely, but in addition to it, opposite expressions. Opposite expressions are monomials, binomials, trinomials that have the opposite value. So for example, if I said to you, the binomial 2x plus 1, and I said to you, what is its opposite? Mike, what do you think the opposite of the binomial 2x plus 1 is? I'll give you a hint. I'll draw it for you first. There's 2x, and there's a positive 1. What do you think its opposite expression is? Good. The opposite would be negative 2x minus 1, and that's the important part. Most people will say negative 2x plus 1, but it's negative 2x minus 1. Each of the terms has to be its opposite, right, in order for it to combine to make 0. And we know that, I guess we know that best from looking at it pictorially, because we see how these two are going to make what? 0. And we know that these two are going to make 0. So therefore we know that those two terms, when combined, will create 0, right? Common mistake is everybody just says negative 2x plus 1, but that's not true, okay? I gave you another one, said negative x squared plus x minus 4, and I asked you, what is its opposite? Riley, what would you say the opposite of that trinomial is? Good. Simple as that. minus x plus 4. And the easiest way to see it is by drawing it. There's negative x squared plus x minus 4. Its opposite would be the opposite picture of this. No, it doesn't. No, it doesn't. But again, since we did declare before that to keep things copacetic, all terms should be arranged in descending degree of terms, which probably would always lend itself to having it written in the correct order. But you don't have to. You're going to see test questions that don't do that. Okay? Everyone sees here from the picture, makes a 0, makes a 0, makes a 0.